But my interpretation of this is right now we're vulnerable, but if we get our act together, we don't have to, we can reduce our vulnerability enormously. Now, you know, and what are the potential? You just named several impacts, volcanoes. I think the sun needs to be included. The Carrington event of 1857, Rob's going to look that up for us. But we now know that there have been events.
Carrington event, you said?
Starting with a K, there it is right there, was the most intense geomagnetic storm in recorded history, peaking on the 1st and 2nd of September 1859 during solar cycle 10. It created strong auroral displays. Now, if that would happen now, I mean, it could really put down the electric grid. That would take a year, a couple of years, perhaps even to restore.
Again, what was this? This was a
solar flare.
Geomagnetic storm.
Yep.
Recorded in history, peaking on 1st and 1859 solar cycle 10. It created an auroral display that were reported globally and caused sparking and even fires in telegraph stations. The geomagnetic storm was most likely the result of a coronal mass ejection,
a CME,
from the sun colliding with Earth's magnetosphere. Okay,
yes.
To the average person, what the hell does that mean?
Well, it means that every once in a while, the sun throws off these gigantic blobs of plasma into space. It does it frequently, but typically those blobs are just flying out into space. But once in a while, one of those blobs will pass the Earth. And when it does, it can have consequences. And one of the things that it does is it can destroy ozone. It can allow galactic cosmic ray bombardment of the Earth, because normally the ozone acts as a filtering blanket that protects the Earth from cosmic ray bombardment. If the solar storm is intense enough, its own self can cause spallation of neutrons, and that creates beryllium-10 and carbon-14. Beryllium-10 gets preserved in ice cores, carbon-14 gets preserved in plant matter, primarily tree rings, and we can then measure the amount of isotopes, beryllium-10, carbon-14, and determine the intensity of the coronal mass ejection. What we've found is that there is evidence of events minimum of 10 to 20 times more powerful than the Carrington event within the last 2,000 years. Now, obviously, we didn't have an electronic grid encircling the Earth upon which all of society was dependent back in the 700s or the 900s, but now we do. An event 10 times or 20 times greater than the Carrington event, that would cause havoc that could take a decade to straighten out. I mean, it would take down pretty much the electronic grid of the planet. There'd be no more computers. You'd have no more power coming out of it would be a disaster.
Okay. So
now, what do we do about that?
Yeah.
Well, there are ideas in place, but by people who've studied that dimension of catastrophe more than I have, of hardening the grid. And it would be expensive, but it would be minuscule compared to, say, for example, the money we've dumped into Ukraine. It would be, we could harden our electronic systems to withstand a Carrington-level event or even more powerful. Now, volcanoes, there the problem is you got ejection of sulfur dioxide and all these particulates into the atmosphere, which, like you just brought up, the year without a summer. Well, we could perhaps survive a year without a summer. We could. It all depends on how much, this is where preparation comes in. But something, say, even bigger than Tambora, which we know from Earth history has happened repeatedly, that's just in recent Earth history, since we've been keeping records. If we look at Toba, for example, it was many times larger than Tambora. But the point is, are we prepared? Well, what we would need, again, is lots of it. We would need a national stockpile of food. We would need backup generators, because we could literally maybe go a couple of years with drastically reduced agricultural output. We'd get through it because the atmosphere would clear out. Now, an impact event, like if we took the June 29th episode, that would have consequences that would take at least 5 to 10 years, probably, for everything to recover in the aftermath. But in that recovery time, you're going to the problem is you've got the first impetus, which is the impact itself or the volcanic eruption itself. Yeah. Then you've got all the secondary consequences and the feedbacks and things, which would, so initially, like I said, with the impact of a 600 or 800 foot wide asteroid, it would instantly kill a few million people, depending on where it fell. If it fell in the ocean, now you're going to have tsunamis that make landfall that could be 200 feet high or more when they make landfall. So, I mean, you could have a tsunami that could literally wash over the entire peninsula of Florida. So you can see there, like if it fell in the ocean, it could probably kill more people than if it hit land. But if it hit land, now you've got all the debris that goes up, and as it falls
Very interesting. I got what you're saying.
Yeah.
So it's better it hit land and it hit water.
Yeah, probably so.
Okay.
Depending
on where you hit, what...
Yes, and the other consequence of hitting water, of course, it's going to be like Hunga Tonga Hunga. It's going to throw all of this water vapor
we can't
into
have
the
that.
atmosphere.
That's a real situation.
Now, see, the thing is, there are studies now showing that impacts can induce accelerated and concentrated volcanic response in the Earth's crust, which makes sense. You know, if you think if you got a major impact, it hits the Earth. And then look at the work of Michael Rampino. He's done some great stuff on this going back to the 70s, showing the correlation between impacts and volcanism. He's not the only one. There have been many others. Yeah, there he is. Yeah. I've been following this guy's work for years, since he was a young fella. And I was a young fella then too. But yeah, he's done a lot of work on the.
Let me be a skeptic here.
Please
Just
do.
Push back a little bit and tell
Yeah.
So for me, okay. You're telling me you're going to be able to control a meteor from hitting us and destroying civilization. That's what you think you can do. Okay.
I know we can do it.
Okay. So number two, you got the volcano, which is, forget about the 1815 one, which is the Tambora.
Yep.
The caldera, right? You've seen what happens if the caldera Yellowstone goes off. That's pretty crazy as well if that takes off. You think you can prevent that from happening?
No.
Okay, so that one you can't prevent from. So there are certain things that we have.
Right.
That whether we like it or not, there is nothing. If it happens, guess what? Make sure you get on your knees and drop your last prayer if you got time. And hopefully you chose the right God, and we'll see what happens after life. And if you don't, that's the risk you're taking, right?
Yeah.
We'll see what happens.
Well, my take is that you can't prevent those things from happening, but you can prepare and you can buffer the impacts of them. That's the thing. If you factor that into your thinking, your long-term strategic planning, yes, you can mitigate the effects. You can't prevent it. Now, as far as preventing an asteroid, I mean, if you're talking about, a mile-wide asteroid, there's nothing we could do about that now. But, the DART mission, we just were able to rendezvous and show that we could actually rendezvous with an asteroid and we could actually move it in space. So the key there is having enough lead time, because these things that have Earth's number on them, and there have been thousands of impacts, and there will undoubtedly throughout, the next million or few million years, another 1,000 impacts. What are we looking at? There's DART, Double Asteroid Redirection Test, and it showed that we can do it. Now, are we capable of diverting an asteroid that's on a direct Earth impacting trajectory right now? Probably not. Could we be within 5 to 10 years? Well, yeah, if there was the national will and vision and motivation to do it. And probably, Pat, what it's going to take is another Tunguska event to shock people into realizing that whether we like it or not, we live on a planet that's part of a larger cosmic ecosystem, and we need to adapt to that. And the most devastating catastrophes in Earth history, I believe, and there's quite a bit of abundance that would support this conclusion, is that the one that kind of encompasses everything else is cosmic impacts. And if you saw the number of close encounters over the last 20 years, it's kind of mind-boggling. It is. I mean, 2 or 3 times a year, we're having close encounters. And, Tunguska, okay, that was that's a speck in cosmic terms. Now, could we do something about the problem with Tunguska was It came from the direction of the sun. It encountered the Earth right after its perihelion passage, meaning it had just passed the sun. And so when the eyewitnesses saw it, it looked like it's coming directly out of the sun. People said it was born out of the sun. Some of the Tungusi tribes people that witnessed it said it looked like it was disgorged from the sun, that it was born out of the sun. Now, it was likely, in my opinion, part of the Taurid meteor shower. And the reason is the Taurid meteor shower peaks at the end of June and early July, and the summertime Taurids at that period, there we go. Okay, they're coming from the direction of the sun at that time of year. So its position in space and its time in the year were both suitable for it being a member of the Taurid meteor stream. And the Taurid meteor stream is an old meteor stream that probably resulted from a really big comet that came into was captured into the inner solar system between 25 and 30,000 years ago. There we go. An annual meteor shower associated with the comet Encke. But Encke would have not been the original comet. Encke was simply a fragment of the original comet. The original comet probably did what Shoemaker-Levy 9 did. It came in and broke up into multiple pieces. And then those broke up into multiple pieces. And it's been going through this hierarchy of disintegration ever since. It is the most likely candidate for the source of the impacts on Earth at the end of the last ice age, the so-called Younger Dryas impacts, which, very controversial theory, but I think the evidence now is pretty much overwhelmingly supportive of the fact that, yes, Earth got bombarded around 13,000 years ago.
Is there anywhere that meteor has never hit Earth? And let me explain what I mean by this. Here's what I mean by this. Is there like a... like in U.S., if you were to pull up numbers and you say, hey, last year we had this many murders, okay, homicides. And I can say, can you give me the top 3 cities in America for homicides, okay? Okay, number 1, let's just say Chicago. Number 2, D.C., Baltimore. I don't know. I'm just, those are some of the numbers that you'll typically hear. Rob, if you can just type in top 3 cities in America and homicide, okay? So then I'll say, okay, so where does it not get it? Boise, Idaho. Just because, hey, why not Boise, Idaho? Well, because Boise, Idaho has, the most people that are licensed to carry. Boise, Idaho is the worst place for you to want to commit crime because it's open carry state. So, oh, no shit, I didn't know that. Okay, so then it's kind of telling me stuff.